Welcome everyone here for the second Academy workshop, where we'll be joined by Alberto Viera to learn a bit more about blockchain transaction flows, tools, signatures, and UX. Alberto is the founder of Papermoon, a developer relationship software company, and Alberto is here today to represent Moonbeam, I believe. Sorry about this.
Yep.
I had a little note from Jake. Yeah, here to represent Moonbeam, as Papermoon is a core contributor to the Moonbeam network. I think we'll take questions rolling, Alberto, if that's fine with you.
Yep.
And then it's just going to be on like a raise your hand kind of basis. And then we'll stop whenever it's convenient for Alberto. All right, take it away.
Yep. Thanks, Vincent. Yeah, I see a bunch of familiar faces. I guess I've been long enough in the space to remember some of you guys. So, yeah, great to be here. Yeah, I mean, as Vincent mentioned, I'm Alberto. I founded a company called Papermoon that provides developer relations as a service. But, you know, I've been a core contributor from a dev perspective to Moonbeam since the project started back I joined in June 2020. But we also do, you know, developer relations contributions to other projects out there, like, for example, Tansy. But, you know, today the talk is not going to be about Moonbeam itself. The idea of this workshop is to do some generic, you know, and even it's kind of like a discussion, right? I'm not an expert in gaming. I've never been an expert in gaming. I've said to everyone that I'm good at some games, but it's a terrible lie. But, you know, like the idea is to sort of engage in some discussions and think about, you know, from an architectural and philosophical perspective, some of the things or components that are important in blockchain and transaction flow and everything like that, okay? So, like Vincent said, you know, I do prefer when you guys have a question, just like raise your hand, or even if you want to say a comment. I'm not feeling 100%, as you can hear from my voice, so hopefully. So, I mean, even if you want to just raise your hand so I can take a break and drink a sip of water, that's awesome. So yeah, let's first talk about, you know, traditional game infrastructure, right? So this is very generic. This is not true for all games out there, but it's sort of to sort of like get at the topic into why there's a difference between traditional game infrastructure and when you would then include like a Web3 component. So if you take an example, right, as a massive multiplayer online RPG game, usually the game has two sets of components. One that is completely owned by the corporation of the or the owner of the game, right, entity, team, whatever you want to call it. And then you have the user, right? The user has a way or an access point to access the game, but every single part of the game is owned by this entity. In this case, just for fun, I put sort of you know, a Cats game, and so this is owned by Cats Corporation or Cats Incorporated, right? And then when the user basically uses the game or engages with the game, either through the PC, laptop, phone, console, or whatever, they use an access point that is normally owned by someone, by a third party, by the game itself, and so on. And that's how they engage with the game, right? And the game can have multiple components. This is very, very generic, very not really descriptive. It has some endpoints, it has some servers, it has some databases, and all these components, you know, work together to provide the experience to the user, right? I think probably it's safe to say in this space that all of you have played games in the traditional industry in Web2. You know, like, for example, one example I like to say is like Battlefield, right? I played a lot of Battlefield 3 when I had time in my previous life. And basically, you know, I would even buy like the maps pack. I would buy this extra guns and things like that, right? But what's important to understand here is that all the things that I did were actually owned by the game. I just had the right to use them through their access point, through their gaming infrastructure. Basically, I was just buying it to be able to use it, but they were not really mine, right? Now, like I said, this is not very thorough. It's not meant to be like the one source of truth, but it's sort of to lay the ground of like why blockchain is different, right? And now you have games and blockchains. And so with games and blockchains, things can vary here. Like I said before, this is not the source of how everything is done, but, you know, you have fully on-chain games in which they require minimal infrastructure from the CATS company in this case. Or you have games that use a hybrid kind of deployment in which you have things that are centralized and owned by the CATS incorporation, and then things that are on chain, right? So this is where things get really interesting, because now game developers have a lot of flexibility into how they like build their games and how they utilize blockchains. I remember back in the day, I've been in blockchain for a very long time, and I remember the first games that started popping up would use everything, would put everything on chain. Every single action that the user would take was an on-chain transaction. And then, that created really poor user experience, because imagine you had a game about ships in the space, and you would go explore other galaxies and mint resources and all that, right? Oh, and I have to go to another galaxy. That's an on-chain transaction, right? And you have to wait 10, 20 seconds and then to do the next action. And then if you think how games have evolved, and actually life has evolved, we're now used to sort of like everything being instant, everything happening right away. Even with Amazon, you buy something and you expect it the next day or this afternoon. And in games, it's like that, right? I mean, me as a father, the game that I like the most now is the game that I can just go play 20 minutes, and that's it. I have my satisfaction basically in 20 minutes, and I can stop, come back the next day, because I only have like small time allocations, right? And so imagine you're gonna go that you're gonna play that on-chain game, and out of those 20 minutes, you spend probably, I don't know, half of it just waiting for transactions to execute. And so a lot of games started moving towards like a hybrid experience in which games are off-chain. They still have endpoint servers, even databases. Just I didn't include it here, but they have an on-chain component to truly benefit out of what blockchain is really good on, right? And a couple of weeks ago at Denver, I was discussing with a lot of games, developers, and a lot of them that didn't really know, like they just thought they would use blockchain because it's just, you just tag blockchain into your game, and it's like tagging AI now. If you say that your wallet is AI powered, boom, you have 100 million sales. Game developers need to use blockchain on things that blockchain is really good for, which is settlement and bootstrapping, right? And these kind of things. So, and ownership. I would say those three things: bootstrapping, settlement, and ownership, right? Settlement is because if your game has components that need a source of truth, in the Web 2 world, these sources of truth were centralized to a single entity, right? We're centralized to one person saying this is what it is, and that's it. And that's why in Web 2 games, we didn't see things like, for example, cross-game guns or cross-game things, because who is going to trust who into, like, Alberto owns his gun in Battlefield 3, and he cannot use it in Call of Duty Modern Warfare 3, right? Something like that. While blockchain is really good settling these things because it's decentralized, it's trustless, right? If the network says something, everybody trusts that it's the truth. Ownership, it's kind of the same as settlement, right? I mean, ownership is really associated to settlement in the sense that if I own something, I can prove that I own it, and it's mine, it's not someone else. Settlement's helpful if I'm going to transfer the ownership, right? You can settle the transfer of ownership in a decentralized way. And bootstrapping is because blockchain is really good in bootstrapping incentivization mechanisms and things like that in a decentralized and trustless way. I think we can all agree to this. For example, decentralized infrastructure is really popular right now because you can get access to everyone in the world without having to sort of like go to every single country and have BD teams there and so on. It's really good in from a reach perspective. Okay, so we start seeing games that are kind of like a hybrid mechanism in which you have components that are completely off chain, like for example, the engine of the game, the mechanics, how it works, and so on. But you have things that are on chain, like for example, like I said, the gun, the artifacts, things around the game that just improve the experience. But also another concept that I was discussing at Denver was about the ownership of the game and the governance of the game, right? Imagine you have a game that you have like a damage ratio for each gun, and the gamers are like, man, this sucks. This is really overpowered, right? This little gun here is really overpowered, and there's a mechanism in which everyone can vote on a decentralized trustless network and say, hey, we want to vote to lower this, damage multiplier by this gun, right? You can start like engaging with this really cool mechanisms, because now you have a combination of blockchain technology, but also you have the benefits, and everyone has to agree that there are benefits of Web2. Like Web3 is not perfect, right? And so you can sort of reap the benefits of both worlds. And I think this is to me what's really exciting about games on chain, and that's my opinion. I don't think everyone has to agree on this. But yeah, this definitely creates a really, really new, interesting dynamics, right? And now also the user is different. How the user engages with the game is different, right? Because they have a sense of ownership of the game that they buy. They buy a game and they have now a new sense of ownership. While in previous days, right, I bought Battlefield 3, I play for it a lot. I played a lot, right? And then now they discontinue supporting it, and that's it. All the money that I put in there, everything that I put in there, is completely gone, right? So while if you put some on-chain experiences around the game, even though the game dies, some of these things can go on, right? Even if I'm like a General 3, whatever division, whatever, that thing sticks with me as I move forward. So yeah, go ahead, Deco.
Hey, yeah, I think it's really interesting because a few, maybe a month or years back, there was a lot of things were like token gated PFP projects that kind of gave you the access to the game. So basically just the key was to the game was on chain, and then the rest was off chain. And now I feel like the trend is going towards like this FOCG, like this fully on chain gaming narrative. And that's swinging into the opposite direction. And I see like also ethical debates about that. So I'm interested about like, where do you see kind of the sweet spot? What do you say? Like, is it the sweet spot really capturing on like this only like the meaningful ownership, and what kind of for you would be something like meaningful ownership? Because that's what we discuss on a very frequent basis. How much of the like not so important stats do we keep on chain? And how much of the, you touched on the weapon stats, for example, and you said like there is a multiplier in between. That's how we solve it. But I'm just interested in your opinion on this.
Yeah, I think it's a good question, right? And like, well, it's a good comment. And I would say that what's really important for me is that you ask the question is that, how is blockchain solving my problem? That for me, and that's a question that I ask every single team that I talk with. It's like, how is blockchain solving a problem that you have, a real problem, right? Like I said, tagging blockchain to your game, if it doesn't make any sense, then it's just BS. I mean, it doesn't make sense, right? But how blockchain solves a problem, like I said, it's like settlement, ownership, and bootstrapping. And so if you want to put every single action on chain, in a blockchain that is not meant to do that, you're just going to create poor user experience, right? I mean, and that for me is like, I don't have an answer to say that, you have to find the right balance of what things are important to put on chain because you're actually using on chain or blockchain in the smart way, or what things you put on chain just to say that you have a blockchain game. I mean, think about Axie Infinity, right? I mean, even though it was, sorry, I think someone muted me, but that's fine. I am muted already. So Axie Infinity, think about it. Even though nobody thinks about the game anymore, they use blockchain so well, just because of the hype they created and all the stuff they created around the game and the on-chain mechanism of like play to earn and all of that. They used that very well. But maybe not everything had to be on chain, right? I mean, not everything in their game was on chain. But what I'm saying is that the question that you got to ask is like, how blockchain helps my game, and which components of my games should be on chain. I think people that feel that everything should be on chain are just maximalists, right? They're not practical people. Like I said, like Web2 is good in so many things, but Web3 is not going to solve everything. Like Web3 is not meant, at least in my opinion, to solve everything. Web3 is to solve certain problems that exist in Web2 and exist in the world in a way that where you need decentralization, trustlessness, and things like that, right? And so for me, that's my sweet spot, basically. A hybrid mechanism in which you leverage the good things that you have from Web2 and centralized technology with the benefits of blockchain.
Yeah, I definitely agree. I think this is for me, it will be interesting to watch kind of where this what the market starts to accept and where the sweet spot will lie, because I think we can settle on this kind of fully on-chain, like everything. The UX will just forbid that this will settle like this, but on the other side, like finding out like what is meaningful ownership, what is meaningful transaction, and so on. So this will be pretty interesting to watch where this is going. And I think like no one knows the answer to this. This is still kind of developing, and
I agree.
We're talking about. Yeah.
I think, you know, like going back to NFTs and ownership, right? If I have a gun that it's an NFT, right? And then no other game accepts it, it's just the same as the Web 2, like in the Web 2 world, right? Because like, oh yeah, oh buddy, I have my gun, it's so beautiful, but there's no usage to it. Like there's no utility, right? And so at the end of the day, it has to be like a general shift in like how people see games and how they use it. The benefit of having on-chain though is that even though the game dies, the gun doesn't die, right? And so another game can come up and say, hey, I want to use all these assets that were created by this other game, and I can leverage them through this like technology, right? And so I don't know, it's a good topic, and we could probably discuss like a few hours on this. Someone raised their hand. I think it was like some dev.
Yeah, I just wanted to ask, like, what would be the incentive for another game to pick up other games NFTs and basically give value to something created by some other company?
Yeah, I mean, I'm going to give you an example in a non-gaming example, right? But SushiSwap, when SushiSwap launched, they vampire attack Uniswap, right? I mean, there's if you can tap into another game's success, right? You can just bring more utility, and you can like sort of, you know, tap into their market, right? At the end of the day. And so I think that would be one way to put it. Imagine there's like a really, really hot game, and you know, you say, hey, I have now another game that is to auction things out of that game, right? I mean, you can create a secondary market. And so it's basically now you have this on-chain component that allows you to create other things around a game that are not necessarily related to that game. You know, I've not seen like an example of this, to be honest, but I think it's a really cool thing to explore, right? And not everything will be utilized. You know, like I said, I think if there's something that is really niche and there's not really a secondary use or another utility, it's just basically like a branding strategy. But I do see some ideas or some examples where this could be really beneficial, right?
I think there's some pretty obvious examples, right? Like let's take those big PFP projects that promise like the whole world and not deliver anything. And then if you're maybe, for example, a small indie studio, you can just like take that audience, build a cool experience for them, have like all the eyes on you because you're actually delivering something, and you didn't have to do any community building. They basically built themselves, and you just build a game for them, basically. So I think there are a lot of scenarios where this can be even mutually beneficial between two games that are already building.
Yeah, I agree. Even one studio, like if they launch two games, right, they could sort of like reap the benefits of having this on-chain component, so that, you know, they're still sort of like utilizing things from other games, and they can sort of like, you know, share spaces, right? So I would say so. Yeah, go ahead, Sigmeet.
Hi, it was nice to see you again.
Yeah, I agree.
So I do think that you are right. And there's one scenario in respect to games, which is very particularly good, is if some games have a very good audience, like Call of Duty or something, they can even increase microtransactions of NFTs by NFT staking. And then other games can have the benefit. They can pay the Call of Duty or some other gamer studio some revenue back, saying you can like 1% of it or 10%, X percentage of it, to try our new game for your gamers. Because in the end, gamers will, if it's not good game, gamers will leave. If gamers are not given more opportunity, there's always like advertisements, right, in the game. This could lead to a revenue sharing model in which you do not lose your gamer, but you get other games to try. Right, like if you have
I agree.
Yeah.
I mean, the question is like the chicken. It's kind of like the chicken and the egg, right? Like, why would a game launch something with NFTs that other game can tap into? But at the end of the day, like, it's going to be like a battle to who does it best, right? I think
does it.
Yeah, and so we see like Mythical that they launches like NFL games in which the things are NFTs, but are they really usable by other? Like maybe not. Maybe it's just like to be sort of like self-served by mythical games kind of things. But we'll see, to be honest. Like I think this is a discussion that can go on for a long time because it's not a fact. It's just like what if, right? And so, but it's a great discussion. I agree, right? But at least the idea, my opinion, because I don't want to say that this is the truth, is that you got to think about how you leverage blockchain the right way. That's the idea that I want you to keep to yourself, right? It's like just saying that I mean, there was a game that I played. It was a hackathon in Moonbeam that they did, like this space game that I told you about, where every single action went on chain. And I asked them, but why? Like the typical meme, but why? And they couldn't answer the question, you know, like, why is every action on chain? That doesn't make sense. Like your NFT doesn't have to like, the game doesn't need to like care if my NFT went to another NFT to do an action. You can just do the action directly there, right? So this is the question for me, like use blockchain wisely and just don't make everything on chain because it doesn't have to be on chain, okay? Cool. User and blockchain interface, right? So let's discuss about the different, like, kind of like how blockchain works, right? And so a user interacts with the blockchain generally through a wallet. A wallet holds a private key, and the private key basically represents a user on the blockchain, right? And wallets can be of different kind of shapes. We're going to go into wallets a little bit later. What's really important to understand is that generally speaking, and this is not true because there are also technologies like DIDs or decentralized identities that really, like, you know, make this statement not true. But anyways, to the blockchain, a transaction, the blockchain doesn't really know where the transaction came from, right? If it's Lucas or Descartes or Samit, the blockchain just knows there is a private key that signed the transaction, okay? And this is really important because I get a lot of people in Telegram where they say, hey, my wallet was compromised. I need your help recovering my funds. And I'm like, I can't really offer help because I don't know if you're you or you're the hacker, right? I mean, to the blockchain, everything is completely transparent and I don't know who is who. There's no way of knowing who is who, right? Transactions are signed or authenticated by a private key, not by a user, all right? Like I said, with DIDs, which is really interesting for games if you think about it, this statement changes a little bit. With DIDs, you can know that Alberto signed. You can know without me revealing that I'm Alberto, that Alberto signed a transaction, right? Which is really powerful, I think, in gaming. And basically, a signed transaction is an intent or a user interaction. That is, I want to do something on the network, and it's signed, like I said, via a private key. And so the private key really represents the user on chain. In Ethereum, and we're going to focus on Ethereum because I think Ethereum is probably the most popular game stack here, and I represent Moonbeam, which is Ethereum compatible. So I identified basically 3 different kind of accounts. The first one is known as an EOA. If you don't know what an EOA is, it's an externally owned account. It is a user that submits a transaction signed via a private key. And the private key is derived from a seed phrase, right? So this is the order of things. You have a seed phrase, which is 12 words, 24 words, whatever. And from that seed phrase, you can derive multiple wallets, okay? With multiple private keys on multiple networks, right? So how this works at a very high level is that there's something called the derivation path from the seed phrase to a private key, okay? And so from a private key to an account on a specific blockchain, okay? So for example, if from a mnemonic, from this 12 little words here, you want to derive a Bitcoin account, you would go to a specific path. This is including cryptography and things like that. Basically, you would go through a specific path that will take you to a Bitcoin address, okay? In the case of Ethereum, it is basically this path, which is 4460000. And then basically this means that, you know, if you have some words and you direct them with this basic derivation path, you will get 1 private key on Ethereum. And if you change this little number here at the end, you get the second account, the third account, the fourth account. That is why in MetaMask, with a single seed phrase, you can get multiple accounts that are associated to the same seed phrase. It's basically because you change this little number here. But there are multiple ways of getting different accounts on Ethereum. But yeah, this is not relevant for this presentation. What's important that you need to understand is that EOAs are basically users or wallets or addresses that are associated to a private key, and basically this is derived from a seed phrase, and the transaction origin is the actual user signing the account. Okay. The second type of account, I would say, are smart contract wallets, right? So this is the first kind of account abstraction that ever existed. People think that account abstraction is something that is hot right now, or it was created 5 months ago on Ethereum, but the existence Ethereum has existed. All right, there are just different levels of account abstractions, right? And the first one was smart contract wallets. If you don't know where a smart contract wallet is, it's basically a wallet that is a smart contract. It's just that, right? But basically, the wallet cannot submit transactions, right? The wallet doesn't have a private key, so it cannot submit a transaction to the network. Someone has to trigger a transaction via their private key, and then the wallet will do an operation it was initiated by that private key. Okay. One of the most famous smart contract wallet is Gnosis Safe, or Safe nowadays. It's a multi-sig wallet, smart contract wallet, which allows you to do multiple things that an EOA cannot do. You can batch transactions. You can have a transaction to be executed on the blockchain only if X out of Y people approve it. So smart contract wallets are really good because it allows you to extend the logic of an EOA to something more complex that provides more functionalities, okay? Why I say this is a type of account abstraction is because it is abstracting an EOA, basically. It's removing a lot of the complexity out of an EOA, and you could have smart contract wallets that have social recovery built in, have gasless transactions built in, and things like that. But this, all we hear about that is an account abstraction, the recent things about account abstraction and the ERC and so on. So the way that smart contract wallet works, generally speaking, is that you have basically a smart contract wallet, and then a relayer or an external entity, an EOA, will submit. So the smart contract wallet has a user or an owner, and then you have smart contract wallets that a relayer or the users themselves can submit transactions that are sent to the block producer and included in the blockchain. Okay. I do say the example about Gnosis Safe because it's the one that I've used the most, but I know there are other out there. I think there was one that was very famous early on in Ethereum, but then it became a problem because as Ethereum gas price increased, right, having an account abstracted smart contract wallet was more difficult because everything was on chain and it was super expensive. Oh yeah, I wanna send this ERC20 token, boom, $200 compared to like $50, which is still not cheap, but $50 from an EOA, okay? Because there is a lot of logic associated to smart contract wallet. And then we have the hot kid in the block, which is the ERC4337, which is a kind of abstraction. It's a whole different game. It's basically way more complicated how it works. Ideally, we want to have providers of ERC4337 that abstract all the complexity for developers, for users, etc. But if you're interested, basically how this works is that users now don't submit transactions via their private keys. They just submit user operations, right? So I submit basically an intent to say, hey, I want to do this, right? And this goes, instead of going to the typical flow where you have like this transaction will end up in a block producer that will submit it to the blockchain. This will go to a different mempool on the blockchain that is not basically like transaction. It's not a transaction pool. These user operations are very similar to transactions, though. They're signed. They have a signature associated to them. But the good thing is that because they don't directly submit to the network, there are no gas fees associated. Basically, what happens is that there's a bundler. A bundler grabs these. They actually disappear, but it's there. Believe me. The bundler grabs transactions from this alternative mempool and bundles them up together. That's why the name. And they basically, the bundle interacts with an entry point contract, which is like the gateway or the entry point for ERC4337 and account abstraction transactions to the blockchain, right? Then the entry point interacts with the smart contract wallet. So now you have the smart contract wallet from before, but this is specific to this ERC, and this is what actually represents the user on the network, basically. Okay. The difference here is now that the user will never have to submit a transaction to interact with the smart contract wallet. They just submit an intent. Okay. And then there's a really complex mechanism in which now you have a paymaster. Paymaster is a contract which is optional that can reimburse the bundler for the transactions of the user. This is really cool because you can have, you know, like sponsored transactions. Like there's a team, Glimmer Apes. I think I saw Marin here using something similar, but a little bit simpler to sponsor transactions on behalf of users. And then basically the smart contract wallet then basically, it doesn't submit the transaction to the block producer because that's a bundler, but basically through the smart contract wallet, the block producer introduces the transaction into the blockchain, okay? The good thing is that in Moonbeam, even though you can do ERC 4337, not really, because we don't have an alternate mempool, but you know, Biconomy offers an alternate 4337 implementation that doesn't require this alt mempool. You can do account abstraction related things without really needing all this complicated components, okay? And I'll get to it a little bit later. Another really good thing that I like to talk about, because a lot of people don't really understand, and I think as a developer, it's important to understand at least the basics of how this works. It's an Ethereum communication layer, right? So when you as a developer are, and a lot of people maybe in this call have already seen these slides, but when you as a developer are using any Ethereum compatible network, the flow is exactly the same. I just put here Ethereum node because it's a true Ethereum implementation. But when you guys are using tools like Ethers, Hard Hat, Foundry, Remix, or whatever, what the tool is doing is translating your code into something called the Ethereum JSON RPC, and basically JSON RPC calls, okay? So if I want to know my balance, or I want to send a signed transaction, or I want to know the balance of Albert token, my balance of Albert tokens, what's going to happen is that you're going to have different JSON RPC calls. For each of these three, you're going to have different methods. So the JSON is not going to be exactly the same. But then basically what happens is that the Ethereum node is able to dissect this call and then basically execute it if it needs to be executed. Like, for example, send a signed transaction, or in this case, relay it to the network. Or if it's only a read operation, like knowing a balance or knowing an ERC 20 token balance, the node will basically provide a response with another JSON payload that the tool can interpret and say, okay, you have this balance, or you have this and that, basically, okay? If you want to see more about this, you can check this URL. This is basically the Ethereum JSON RPC spec. And this is Moonbeam's Bible, let's say, okay? Basically, this is what we support at Moonbeam. Any kind of interaction that you do on Ethereum that is based on these specifications, Moonbeam should support it, because this is like the Ethereum dictionary, let's say, okay? This is not all, though. I mean, if you want to be Ethereum compatible, you have to do other things. But let me show you a really, really good example. I mean, well, this is actually an outdated example because this is using Girly, but it's still valid. So let's say you have your wallet, MetaMask, right? And your wallet, what your wallet's going to do is that it's going to use this JSON RPC call that you can see on the right-hand side of the screen, which is basically get balance. And then it's going to pass the address of the user. You can see that Aleph has 442. You can see 442 here. And it's asking basically the latest balance of Aleph to the network, right? And basically, the node is going to respond, hey, your JSON RPC call with ID 1 has the following result. And you can see this number here. And this number in hexadecimal, if you transform it to decimal, it's 0.8971 tokens, which is what you see here, okay? So for you as a user, it's much easier to use Ethers, get balance, and pass the account than having to use Axios, build the JSON RPC call yourself, and do it to the network, right? I know people that are really hardcore and prefer to use the JSON RPC specs, but I wouldn't recommend it because it's really, like, it's not really necessary. But, you know, understanding this mechanics is important because actually now you know how all the JSON RPC all the Ethereum compatible blockchains work, right? This is how Moonbeam works. One of the components of Moonbeam, how it works, which is the client or the node, right? On Moonbeam, you can use the same libraries and tools, Foundry, whatever you like, because at the end of the day, all these libraries, what they're doing, even though they're written in different languages, in Java, C, whatever weird language you want to like think about, all of what they're doing is that they're using Axios or whatever library underneath to do a JSON RPC call to a Moonbeam node. And then we have a little trick, which we have like a frontier, which is a dictionary between the Ethereum JSON RPC spec and the Moonbeam spec itself, right? And so we are able then to provide a response to the tool that they can understand in Ethereum language. And that's it. That's how BNB works. That's how Polygon works. That's how Avalanche works. All of these chains that have Ethereum compatibility at some layer, because in Avalanche it's like the C chain or whatever, and in BNB is actually based on Geth, so it makes sense that they're Ethereum compatible. But you know, all the chains out there that offer Ethereum compatibility, one of the reasons that's true is because they basically can interpret Ethereum calls into their own language. It's like you have an interpreter here that it's, you know, translating between Mandarin and Spanish, and then, you know, the people talking Spanish and say, okay, what do we do? Okay, no, this is the answer. And then they reply back to the interpreter, and the interpreter says, okay, this is the answer in Mandarin, right? That's it. So for developers, this is what they need to know, that, you know, Moonbeam is just a black box, that it just works like magic. But, you know, like I said, this is also true for any other Ethereum JSON RPC, Ethereum compatible chain. I only said this is one side of the thing because the other side is to have an EVM, right? An EVM is like core layer of Ethereum compatibility, right? And so basically, if you go back to how a transaction flow is, at some point that transaction is gonna go to the EVM, and the EVM is a machine, the computer that can say, oh, okay, this transaction actually wanted me to do X, Y, Z, and it will execute a transaction, okay? So the EVM is like the base layer, but then Moonbeam offers a lot of other things. Like, you know, we offer a lot of expanded EVM features, fast finality. You know, we have Web3 RPC support, which is what I just showed you guys, and other things as well, right? But everything starts with an EVM, and then you start building on top of an EVM other things. That is why, for example, a lot of teams have an EVM, but they don't really support all of the JSON RPC stuff because they're still building this layer here, this Web3 RPC layer. This on Moonbeam is really, really complete. But in other chains, not all of them for sure, but on other chains, it's not that complete. So they can say, okay, you cannot do this in my chain because I don't support yet that RPC method. Okay. So yeah, let's discuss a little bit in more detail how a transaction flow is. Okay. So on Moonbeam, and like I said, this is specific to Moonbeam, but this applies to at a high level to every single blockchain out there, right? On Moonbeam, you communicate with the node. The node, when you sign a transaction, you communicate with the node. The node basically, you know, can be like, hey, you know, via MetaMask. You're telling the network via MetaMask that you're doing a specific action, like sending a transaction. And then basically the node will start interacting with some of the modules in Moonbeam. One module is, I call it the Ethereum model because it's easier. This validated transaction, basically this module says, okay, who was the signer of the transaction? Who is the private key that signed this? And so the private key is address 0x12345. All right, makes sense. I'm going to actually send this transaction to the EVM because I validated already, okay? Note that the transaction is not saying, this transaction is from Lucas or from Alberto or from Deckard, right? This transaction is from this address, and that's it, okay? And so now that the module has validated the transaction, it will actually send a transaction to the EVM. The EVM will say, okay, this transaction is basically sending 1 Ether to Lucas, so I'm going to execute that change in state. All right, so in block N, Alberto had 1 token and Lucas has 0. In the next block, Alberto is going to have 0 and Lucas is going to have 1. That is decided by the EVM. So the EVM is like the rules that govern the game, basically, okay? And then you have the execution result with some logs, where you have like a transaction hash, block hash, the from, which is related to the private keys, the to, which is whatever interaction we're doing, and so on, okay? If you want to know how this looks in real life, this is how a transaction receipt looks like, right? This contains all the information associated to a transaction, an interaction with a blockchain that is Ethereum compatible. You have the type of transaction, you have the nonce, which is basically the amount of transactions the user has on the network. You have the from, the to. Anyways, everything has a meaning here. It's not nothing is meaningless. And this right here is the signature. This R and S are associated to the signature, and so on. Okay. I did say, and this, maybe for Moonbeam I had to talk about this because you're all building games. And one thing that is really unique to Moonbeam is how we complement games on providing things on top of the EVM that are not EVM standards. Okay, so there was this phrase that I heard in November. Sorry, let me try to do some memory here. We are EVM equivalent, meaning that what you expect from the EVM on Ethereum we can provide, but we provide more than just EVM equivalency, if that's even a word. Okay, so the way why we can do this is because Moonbeam has the Ethereum interface, JSON RPC, EVM that I talked to you about, right? That's all standard. There's nothing weird about that. This is everything that you probably know already about Moonbeam is there. But we also have another layer that it's called a substrate layer, or the Polkadot SDK layer, which is how Moonbeam is built on top of, right? And so this is very modular and allows us to do things that are really outside of the EVM realm. That's why we have like staking. This is native staking. This is not done through a smart contract. We have native governance, native interoperability. We also have other really cool things that can do things that are not possible in the EVM. But you cannot interact with the substrate interface using the Ethereum interface, right? So from a smart contract, you cannot tap into staking or governance because that's like a different language. That's substrate. That's not EVM language. However, through Moonbeam, we provide a set of precompiles that allow you through the Ethereum interface, through smart contracts, to tap into this functionality. And this is really cool because from games, from a gaming perspective, you can do things that are not really possible, in any standard EVM implementation. And I'm pretty sure that Moonbeam has to be like the chain that has most precompiles out there. Ethereum has precompiles, by the way. Moonbeam has all of them as well. But no, precompiles is not something that Moonbeam created, but Moonbeam is leveraging quite well. And so basically with Moonbeam precompiles, you can forget about knowing Rust or anything that Moonbeam is built on top of. You can forget about the Polkadot.js SDK, the JavaScript or TypeScript library that allows you to interact with the substrate side of Moonbeam. Or you can forget about Polkadot or substrate specific terminology. I can throw some terminology here that you probably have not heard in your life, which is a good thing, right? Like wait, or proof of ref time, or proof of validity, and things like that. With Moonbeam, you can forget about that, and you can focus on the functionality, right? It's kind of like the same question that I asked you before about what blockchain can do for you. In this case, is like what can the precompile do for you? We have a very extensive documentation on all the precompiles that we offer. You need to know the precompile address and the function to call, basically. And it's as simple as that. It's basically a smart contract, even though it's not a smart contract. But to you guys, it is a smart contract, which you can do really, really cool things. So if there's no questions, I'm going to give a couple of really, really cool examples of precompiles to improve user experience. And I think this will be really helpful because this will allow you not only to reduce gas costs, but to also provide really a lot better user experience for your games. Oh, thank you, Marin. By the way, I will share the slides at the end, and so that all these links and everything will be you'll have them if you want them. So, excuse me. The first precompile is called the batch precompile. All right, this is my favorite because it's so easy to understand. It's a no-brainer. I am not going to sort of walk you through it, the precompile, because that's a little bit out of the scope of the presentation just because of time. But I'm going to explain to you high level how this works. Basically, the batch precompile can help you batch transactions into one without needing a smart contract wallet, right? Without needing account abstraction. An EOA on Ethereum cannot submit multiple transactions in one single signature, okay? One signature, one transaction. On Moonbeam, because we're modular, that is not true. You can have multiple calls, call 1, call 2, call n, and basically your application can then call make the users call the batch precompile to submit the transaction to the network, and then the network will understand, oh, okay, this is actually n calls, so I'm going to execute them all. And then you have different ways to execute the transactions. You can execute them all atomically, meaning that all of the n transactions have to succeed in order for the entire transaction to be successful. You can execute them until they fail. So for example, 1 is successful, 2 successful, 3 fails. I'm not going to continue executing, but 1 and 2 will be executed. Or you can say, hey, only execute the ones that succeed. I don't care if 2 fails, but if 3 succeeds, keep going, buddy. That doesn't really matter, okay? So I'm going to give you one example, which is like a no-brainer. If your game has this, it's a no-brainer if you've not implemented this already and you're built on Moonbeam. A shop, like a shop, a marketplace, whatever you want to call it. Imagine you're in a game and you want to, I'm going to, create a game here right now. So you are playing a game in which you walk into a shop and you want to buy armor, jewelry, swords, bow, arrows, whatever, right? Unless all these things are under a single NFT, if you're using this for an on-chain component, if they're not under a single NFT, you're screwed. You're going to have to do one interaction per, one transaction per interaction, right? So that is a shitty user experience because it's like, oh, I'm going to buy arrows. Oh, shit. Okay, wait. I have to wait 10 seconds. Oh, okay. Now I can buy the helmet, whatever, right? But with the batch precompile, you can create like a marketplace experience in which you can just like add to cart, add to cart, add to cart, pay, right? And then one transaction is signed, and that's it. You have it. That's how Amazon works, right? And Web 2 is great offering that. It's just perfect. But, in our world, in the on-chain world, that's not really a possibility unless you use like smart contract wallets or you use a single kind of like contract that your EOA can interact with, right? I see this as a no-brainer for marketplaces, like NFT marketplaces, right? If you want to buy multiple NFTs, you can buy it in one single transaction. I think other games have implemented. I know, for example, like Glimmer Apes implemented this on Moonbeam. But for example, I remember, I think it was Exile Racers. They had a minting experience that was super good. It was like you were coding your minting experience. You had to type some codes into a terminal, and there was but then, I had like 4 or 5 NFTs and I had to submit 5 transactions. And I went to the chat, it's like, hey guys, you know that you can use a batch precompile so that, if you have to mint 5 NFTs, it's only 1 transaction. Basically, you blew up the entire minting experience by me having to sign 5 transactions. I was so excited with the minting of the NFTs. And then I was like, this is so annoying, right? That can prevent that type of experience, okay? Let me see if I can share with you. Yeah, okay. So this is basically the batch precompile address, okay? And here you can see that it's actually quite used, right? You can see the method, you can see the transactions. Let's see, for example, this one right here. Oh, wow. These guys did, I don't know what they were doing, but they did, this seems to be Moonwell, but they did at least 6 transactions to a single signature. And you can see that they have 56 logs, all right? This is crazy, I mean, if you ask me, right? But this is one single signature from a user, and they managed to remove, basically go from 6 transactions to 1. If someone thinks that this doesn't improve user experience, I mean, I would like to know why. But this is really, really cool, right? Let me just grab another random one that it's fairly expensive. Let's see this one. This is also Moonwell. Let's use a batch sum. This is Bifrost, I think. So Bifrost is using the batch precompile to do some things around there, like liquid derivative stuff. But it's really cool to see, to be honest, because overall it's just better user experience. Yeah, still have some time. Great. The next precompile, it's for me the one that provides the best boost in user experience, but it's the one that it's a little bit harder to implement. And the main reason is because we have not found a sort of like a company or like a service provider around this, right? And so teams have to do a lot of the infra themselves. And I know for a fact that, for example, Glimmer Apes is using it. I think Marin is here, yeah. So Glimmer Apes is using it, and they have to do their own infra to use it, right? Which is still pretty cool, you know. Like they did all this stuff, and I wouldn't say it's extremely hard. So kudos to them as well. But you know, the call permit precompile, which is probably a terrible name, makes any transaction gasless without you having to modify the smart contract. So if you know gasless transactions, it's a way for you to so that users can submit transactions in your protocol without them having to pay for gas. Normally, in the typical Ethereum world, how this works is that you go to Biconomy or you go to a gasless transaction provider, and they tell you, okay, in order to support us, you have to do this implementations in your smart contract. So this introduces extra risk. You have to modify the smart contract, which is not always great, and so on. With this precompiled, you have to not modify a single line of code. And the proof of that is that actually we have a tutorial in our documentation in which there's another game on Moonbeam called Dan Paris Society. And we actually, without them knowing, we grabbed their contracts. We created an example in which you actually use your game in a gasless way without having to pay for gas, without them even knowing, right? Because they didn't have to modify anything. So we just grabbed their game and made it better for a single action. It was not better because we didn't embed it into a UI. You had to do it manually, which is not great, but you get the point, right? And so dApps can submit the user's transactions. That's how Glimmer Apes guys are doing it. And it just provides better user experience, right? So let me explain how the game, the Glimmer Apes game, is actually using this, basically, right? So you have happy users. In this case, in their case, it's not even happy users because they offer a model of a non-custodial wallets. Basically, they own the wallets of the users until the users decide, hey, we want to actually get our own stuff, and then and we want to hold it ourselves. I mean, Marin, hopefully I'm saying it right. But basically, the user can play the game without them having to do anything. They don't have to own a wallet. They don't have to do anything. But what's happening underneath is that a wallet is created for them. And so basically, the team submits an intent. They sign a transaction on behalf of the user. The user doesn't have access to the private key, but at least there's like a mapping of like, hey, this user has this address, okay? And basically, the team signs an intent through their backend, basically. And basically, they have a relayer, which is another entity that acts like a gas tank, right? So instead of having to distribute Glimmer to 2,000, 3,000, 5,000, 10,000 users, or 10,000 of these accounts, okay, that they custody on behalf of their users, they just refill one single address, which is a relayer, a gas tank, and then the relayer can submit the transaction to the network via the call permit, okay, the call permit precompile. So basically, if someone signs an intent, someone else can submit this transaction through the call permit to the network, okay, without having to modify a single line of code, which is really, really amazing, right? Because in the case of their game, they're able to provide a game that doesn't necessarily tell the user that they're using blockchain, but at the end of the day, they offer the possibility to the user to say, hey, I want to benefit of all the things that I gathered in my game or whatever, and then the user can take control, right? So I think they're using blockchain really well because they're using blockchain to keep track of these things, but then they're letting the user, own it if they want, right? So once again, let's click here and let's see how many teams are using the call permit precompile. I'm actually super happy to see a lot of transactions. Well, actually, that's a lot. I expected a lot less, but you can see basically that this guy, it's a relayer. This is not the real person. And well, yeah, this, I'm not sure which is this, which is this. Is this? Oh, okay, there you go, Mary. I was gonna say if given was something that it was from you guys, but you can see that they're having a lot of transactions through the call permit precompile, and this is their relayer submitting all these transactions basically, on and on. So it's pretty cool to see, to be honest. I think they're all the same source. So you guys are the OGs of the call permit, which is great to see. But yeah, I would invite teams to try this out, just to see if it's able to, if And you can actually build on top of this technology as well, which I'm not sure if you guys, Marin, have actually implemented. But if you guys want to sort of have the game, have the user pay in like doublons or bananas or whatever token, you can create logic on top of the call pyramid that goes through a smart contract and does a swap. Like, okay, you transfer 10 bananas to the gas tank, and then the gas tank will submit a transaction for you. And it's super simple. You don't have to like do much, right? So you can abstract, and if you have an in-game token, you can make all these operations. I'm gonna go to the shop and I'm gonna buy a bow or a sword, and I don't have to pay in Glimmer. I can pay in whatever token game like name you want to give, right? And so this creates really, really good user experience because it kind of resembles Web 2, right, in a way. And think about it, right? You sign the intent, and the game can sort of continue because the transaction is underneath is actually going through. So yeah, I'm actually on time. I think we have some extra time in case there are further questions. But if you want to check this out, I'm going to copy this link so I can share it in the chat. A lot of people are very paranoid about scanning QR codes, which I completely understand. So this is the slides for today. I mean, I'm super approachable in Telegram. If at any point in time you have any questions, you want to keep the discussion going, I get to my messages super, super quick. You can check the Twitter, the Telegram official channel, Discord, or the website for Moonbeam, or you can follow me on Twitter, even though I'm not extremely active there. I do post every once in a while. So yeah, I hope the presentation was kind of helpful at least. And I don't know if you guys have any questions or comments. Cool. I mean, I would definitely invite you guys to at least try out some of our precompiles. Or, one thing that we love to hear is like, what do you want to see from a blockchain, right? Like if you feel, hey, Alberto, it would be really cool if this could be a precompile. Hey, our blockchain technology allows this, right? So, I mean, if you have any ideas of things you want to see, but, Ethereum won't hear you, right? Or like these kind of big companies, but you want to see it and we feel that it's valuable, let us know. I think there was a question from Shimi. Hopefully I'm pronouncing it right.
Yeah, so I just wanted to ask, what's your approach on like multi-chain or like that direction?
That's a great question. And even though, Moonbeam, it's like we touch a lot on like cross-chain, I didn't want to cover this because it could go very, we can extend a lot on the topic. So I was, just before this presentation, I was in another call where I asked a similar question. This is the kind of philosophical questions I like to ask. And the question is, why go multi-chain, right? A lot of people have multi-chain deployments because they just grab their contracts, deploy them everywhere, try to like benefit from like smart contracts, grants, programs, and things like that. But long term, that's just detrimental to their own game because it is fragmenting liquidity, it is fragmenting community, it is fragmenting experiences, right? And so the question that I always ask these teams is like, why go multi-chain? Because going multi-chain is like, it's really, really complex, right? It's not easy. It's not a trivial thing. And so going multi-chain has to be because it provides value to your game, okay? One really clear example of going multi-chain is that you can provide like a storefront to your game for other communities, right? Your game can be in BNB, Ethereum, Avalanche, Polygon, without having to be in BNB, Ethereum, Avalanche, and Polygon, right? You can create smart contracts on these chains that act as a gateway where your logic is still on Moonbeam, for example, right? But you're tapping into all of these communities. And so to me, that's like a no-brainer. If for you, that's important, right? Because other people just say, hey, I don't really care about the blockchain. I just care about, being on chain, but I don't care about, if it's Moonbeam or whatever. I mean, hopefully you pick Moonbeam because we're great. But, I don't really care. I just want to benefit from the on-chain component, but I'm going to extract everything from the user, right? And so that really doesn't need the sort of like multi-chain strategy, because at the end of the day, multi-chain, like the blockchain is not going to be like something visible to the user of your game, right? And so I would say that multi-chain brings a lot of complexities, right? A lot of problems, and you should only think about multi-chain if it makes sense for what you're trying to achieve with your game, right? Like I said, if you want to act it as a storefront to get access from other communities, that's great, right? But is it really necessary? That's an answer that only you guys can answer, because you guys know your product, your game, and so on. Hopefully, at least I shed some light. So,
Yeah.
oh,
Thank you.
sorry. Cool. Any other questions? Awesome. Yeah, I know. And thanks for the Scytale folks and Mythicals for organizing this. And yeah, happy to help anyone via Telegram if they have any questions. And like I said, for me, it's important that if you guys have any sort of like ideas and like things you want to see on blockchains to improve your gaming experience and everything, just feel free to reach out. Okay.
Alberto, thank you so much for this fantastic presentation as well. Thank you to the Moonbeam team as well.
Awesome. Have a nice weekend, everyone. I guess.
Thank you so much, Alberto.
Bye, everyone. Cheers.
Thank you, Alberto.
Bye-bye.
Bye. Thank you, Mike. Thank you, Stripey. Thank you, Vincent.